All right, continuing with our exponential stuff, I'm going to say that we are going to talk about geometric sequences. Geometric sequences are very similar to our exponential functions in a sense that as my exponential function increases, possibly, my ordered pairs, I look something like, my table may look something like this, where as my x values increase by 1, my y values or my output would increase by multiples of 2. As you can see, I'm going up by multiples of 2. Each time I go up, I times 2, times 2, times 2. So in exponential functions, we find out that, that's like a characteristic. Well, that is a definition in when we think about geometric sequences, is that when we have geometric sequences, they are changing by a multiple of either a fraction or a whole number, but that's what is changing each time. It's called our ratio. And so that's what we're looking at. That is the difference between geometric sequences and arithmetic sequences, where arithmetic sequences were linear. It was just about changing a number through addition or subtraction. Geometric sequences are multiplication, or what looks like division. Okay, so a sequence in general is a set of numbers in a particular order or pattern. Each number in the pattern or the sequence is a term. So in this example, they have 1, 2, 3, and so forth. The first term would be A1, the second term would be A2, the third term would be A3, and going on and on. The first term of the sequence is noted as A1, A2, and so on. Finite sequence means that it has an ending. A infinite sequence means that it continues without end. It goes on for infinity. So as I look at this, we'll see some examples of that, but a sequence is a function in which the domain consists of natural numbers, right? Consists of natural numbers, and the range consists of real numbers. I'll take it. Geometric sequence, each term is determined by multiplying a non-zero constant by the previous number. The constant value is called the common ratio. And I will just say, I have it on the next page, but as I'm trying to figure out the ratio, let's just take whatever number we have. So I just say my ratio is equal to a to the n divided by a to the n minus 1. Is just saying n being that sub number, so we're just going to divide it by the previous number. So looking at that, if I use this example right here, this is a to the 1, this is a to the 2, so it would, whichever number I pick, I'm going to divide by. Let's say we're going to start with 3. That would be 3, or think about it, it would be, in this case, a to the third, and then we would divide that by a to the third minus 1, which is a to the third divided by a to the second, which is nothing more than saying, take one number and divide it by the previous number. Okay, that's what we're doing. Taking one number and dividing it by the previous number. And we could calculate the common ratio. So that's what we're going to talk about, creating a common ratio. A geometric sequence, the nth term of a geometric sequence in which the first term is A1 and the common ratio is R, is given by the formula AN is equal to A1 times R raised to the n minus 1 power. What does that mean? Again, if we use this as a general idea, AN is just saying some future number. How do I do that? Well, I take the first term and I multiply it times the ratio raised to the power of those terms. So we'll get some practice in that. So that allows me to pick any term in the sequence, where the recursive formula here says, hey, if we know one term, we can figure out the next term. That's what recursive allows you to find the nth term in the sequence by performing operations in one or more preceding terms. The explicit formula allows you to find any term. So I like to think of explicit. I go to exact recursive, I have to move in order. And then here, geometric means are the terms between two non-consecutive terms in a geometric sequence. So, characteristic connection to exponential functions. Some of the things we talked about: sequences, the term of a sequence identified with your A sub number. Finite means we can count them. Infinite means we can't. Keeps going forever. Geometric sequence means we're multiplying by a ratio. The ratio, how do we find that common ratio? We multiply one term by the previous term. An explicit formula allows me to find the exact number I'm looking for in a sequence. A recursive formula allows me to find the next number in order after I have started off A1. Geometric means we're not going to talk about these last four, or I'm not going to here. I will cover some of that in class. So good luck, and we'll see how it goes. Just some vocabulary here. Calculating my ratio, here it is. I'm going to take to find the ratio, I'm going to take one number, and I'm going to divide it by the previous number, and that's what they've done here. They've taken 6 and divided it by the previous number and gotten 3. 15 divided by the previous number and gotten 2.5, and 30 divided by the previous number and gotten 2. So since these ratios are not the same, this is not geometric. Geometrics, you're going to see the same sequence going over and over again. And that's what we're doing here in this ratio. When they calculated the ratio, it says, find and graph the first 6 terms of the geometric sequence, starting with -1, -2, -4, and go on. So what's happening? They took and they said, okay, I'm going to take one number, -2, and divide it by the previous number, -1. That is 2. I would suggest in these cases you always do 2. So if I took -4 and divided it by the previous number, that is 2. So there you go. I have my common ratio, and I guess it's okay just to do it one time since they told me it was a geometric sequence. And then, so if that's the change, then I know if I needed to keep adding, it would be, I would just take and multiply the next sequence by -2. You know, after 32, I would multiply times 2 and have -64. So it'd be way down there. And that is what a geometric sequence looks like. In this case, a negative geometric sequence. And you don't have to connect lines in this, but if you think about it, if you look at it, that does sort of look exponential. So keep that in mind, that is the connection there. My domain, of course, is going to be 1, 2, 3, 4, 5, 6, because those are my x values of the ordered pair, and then the range would be -1, -2, -4, -8, -16, and -23, because those are the y values. And just showing you right here, that point is 6, -32, which is that ordered pair. That's how they came up with the domain and range, the x and the y's. Applying this, so find the nth term. So now we have to be creative. Javier wants to eat less chocolate each day. To achieve this, he decides to start with a 50-gram bar of chocolate and eat half of it the first day, then half of it is left in the bar the second day, and then, or half of what is left of the bar the second day, half of what is left the third day, and so on. If Javier starts on Monday, what is the mass of the piece that he will eat on Friday? So describing the task, I think we have to remember that A0, when we're starting here, it is 50. So my actual first term is going to be 25. Okay, that first cut in half. So just sort of thinks sometimes how we're manipulating the numbers and thinking about it. So some people might say, well, I'm starting with 50. Yes, that's my starting point. And then my first term would be after I take half of it and eat half of it. Okay, so there you go. Let's see, so looking at that, describing the task, we sort of talked about it. Another thing to think, if we're going from Monday to Friday, he is going to be taking one half of that, over 5 days. So we got to think of that, utilize those seedings, and I hope you can see the character. And then I guess too, and then so if I start with 25 being that first increment after I've started, what would that represent? If what formula represents the nth term of the sequence? Which term represents Friday? How much chocolate will Javier have left? Okay, so we're starting off at A1, A2, A3, A4, A5. So that would be Monday, Tuesday, Wednesday, Thursday, Friday. And then thinking about that, so if A1, I think goes right here. That was my formula. A1 is 25. And then I'm going to multiply by 1/2, and that should be 12.5. And it's going to keep going down. But let's see, if I just went with A5 is equal to 25 times 1/2 to the 5 minus 1, because again, the n value, the term I'm looking for is the fifth term. So that would be 5 minus 1. So that should be 25 to the 1/2 to the fourth power. So depending on if you put that in the calculator, how you do that, I think that is 25 times 1/16 when I do that in the calculator. And that may look a little bit confusing, but if I multiply this out, that becomes 25/16, and that's going to equal some number. And I would just say here, when I sort of did it manually, if I start off with 25 and then I multiply by half, I get 25 divided by 2, and then I multiply by half again, I get 25 divided by 4, multiply by 1/2, 25 divided by 8, and then finally multiplying by 1/2 again, get 25 divided by 16, which is going to give me some number in the calculator, and that would be, it's going to be a decimal. If most people are going to convert it to a decimal, let me just say that. It's 1.5625. Let's just say approximately 1.56. So just, it's much easier to work with the fraction. Okay, so now write an equation to the nth term for each geometric sequence. So we have to remember the nth term, that equation. They're wanting us to do that. What do we need to find out in order to write that equation? One, we need to know what A1 is, my starting point, and we need to know what the ratio is. So A1 would be my starting point. That's where I begin. And then what is the ratio? Taking one number and dividing it by the previous number, or taking any one. So 3 divided by -1 is -3. -9 divided by 3 is -3. 27 divided by -9 is -3. So my ratio is going to be -3. So looking at that, it should look something like a to the n is going to be equal to -1 times my r, which is -3 n raised to the 1. There we go. We don't have to identify what A1 is because it's in the formula. Now here, when they gave us A8 and a ratio, we had to do a little bit more work. So what they're doing here is, if we know that the 8th term is 5, right? A to the 8th, A8th is 5, so I know that this is 5, equals A1 times, they told me the ratio is 1/2, raised to the, again, this is the A8, so 8 minus 1, and that tells us 7. So now we can actually calculate some of the information here. So the only unknown value you have left is going to be 1, so we can just go ahead and multiply that out. Here we get 1/128, so how do you fix that? Well, you multiply by the reciprocal, or you cross multiply. However you like to do it to continue simplifying this fraction or this equation. And then we end up with 640/1. That is my starting point. So A1 is 640. We have the ratio, and then there you go. That is my formula to calculate the sequence. And just being able to work and in the recursive or explicit formulas, a little bit different. That the explicit formula, if we were given if we wanted to find any term and we had A1 in the ratio, we could find it. Well, the explicit is much better in that sense, but the recursive formula requires us to know the number that came before it. So it says, given the formula for geometric sequence in recursive, given a formula in recursive or explicit form, translate it to the other. So here we have A1, AN is equal to 1/5 A. This is going to be my recursive formula. And they're saying that they let me know where to start. Okay, that's why they identify A1. And then, so thinking about it, A1 is 5. Then they tell me that something like I got this 1/5 times A to the n minus 1, and it says the n is greater than or equal to, n is greater than or equal to 2, and what they're saying is, well, you already know A1, so if you're going to move up, you got to start, the next one is 2. Okay, so that would be working with my recursive formula. So let's see if, what do I know? This would be my ratio. So they're saying the times 1/2 or 1/5 times whichever one it is. So let's see. I guess let's just do 2, right? Just to think about what's going on there. If we did, that would be A to the second is equal to 1/5 times A to the second minus 1, which is A to the second is equal to 1/5 times A to the first. So they're going to take the first value, A to the first, and multiply it times 1/5, which is my ratio, and they find out that A to the second is going to be 1. So that is how we're using that ratio. You can see, because in order to find 2, we had to know what 1 is. That's why wherever we're going, they have to give us 1 as a starting spot. Otherwise, it's hard for us to go to continue. And then, let's see here. The way they write the formula is going to be right here. The recursive formula is a little bit easier to understand here. AN is equal to my ratio, not 2, my ratio times A to the n minus 1. A to the n minus 1. That's what we're multiplying by. And they just say, hey, you got to know that A1 is some number. Okay. So again, this is my ratio here. So R is 7. This is my A1, because that's part of my formula there. So those things we know, and when we go to fill it in here, I know that AN is equal to my ratio, which is not that, 7 times A to the n minus 1. And then A1 is equal to 2/3. That would be my recursive formula. Because now we know in the future where we're going to start. So there you go. That is using our explicit and recursive formulas to generate sequences and identify the characteristics of the sequence. You can see here that I have crossed through geometric means. We are not going to work on that as a standard. We'll talk about it a couple of times in class, but what do we need to know here? And hopefully this is going to help. Here, looking at geometric series, we are not going to cover series in this course. You can, and I'm going to mention this and talk to some of the students if you want to learn about it for your ACT and going into higher level math, but right now in our standards it is not a requirement. Geometric series, and here too for series and sigma notation. Willing to help you out in class, but it is not, or in after school, but it is not one of our standards that we're going to cover for this course. So with that,